Hello. Hi. So our next speaker you may already recognize.
That gives it away.
I think. He has been writing Objective-C for 20 years. He works at Next. He is
Worked at Next.
Worked at
Yeah.
Next. I apologize. I'm glad you're here.
I'm glad I'm here too.
He's written books on iOS, Cocoa, Objective-C. He's the founder of Big Nerd Ranch. He's currently focusing on coding, teaching, mentoring, and writing. Aaron Hillegass.
Thank you, Amber. And more than just thanks for the introduction, I think this conference is really very important. There are two parts of the community. There's Apple, and there's the people who write apps for Apple technologies. And there has to be a dialogue between them. And WWDC is really a lot about Apple talking and telling us what we should be doing. And it's nice that there's an alternative voice coming from the community and speaking to everyone at large. But hopefully there's messages coming out of this that are also getting to Apple. So I really want to say thank you, Amber and Judy and everybody involved with the conference for putting this on. I know it's a lot of work, and I think everyone here really appreciates it. So thanks. So before I get started, I wrote these books. I thought I'd start with the first edition of each of them because most people don't have the first edition. My favorite really is the first edition of the Cocoa book, where they gave me the brown cover in the 1970s font and the black and white picture of the inside of the Eiffel Tower. When they sent me the first kind of drafts of the cover, there were things like a slide rule on it. I gotta say, they thought there was Mac programming in 2001. They're like, oh, well, let's do all sorts of obsolete technologies. And it was only when it actually started selling some reasonable number of copies that they got me a real grown-up designer who did the covers that you see now. And then this is actually my favorite cover we did. This was our Core OS X and Unix programming book, which was sort of about Unix internals for the Mac, and it talked about multi-threading and memory and file I/O. And that was before Apple started using Core for everything under the sun. And so we had to change it then to Advanced Mac OS X programming so that it became clear it was not about all the core frameworks. But I love that diagram. When we got a distributor, Pearson now distributes our books, they said that cover had to go because it looked like a 1950s engineering book, and it was too scary for people. And then once I had heard about this idea of it being too scary, when I did the Objective-C book, I went the total opposite direction. We put a tricycle on the cover, and everybody felt comfortable getting the tricycle book. And then this is our iPhone programming book. Back when it was called the iPhone SDK was the first edition of that book. So it's been a really fun adventure writing applications, writing books, and being part of this community. And so I thought that what I would talk about today is network programming. But first, I thought it might be fun to talk about Swift for a second. I'm sure that everybody who gets up talks about their opinion of Swift. I have actually read the whole Swift book now. I sat down, I read the whole thing from cover to cover, and I'm really excited. I think it's a really nice cleanup of the Objective-C language, and it's going to be abstract enough that the compiler can do a lot of things for us that it hasn't been able to do in the past. I think that it's also not really done yet. And if you look at it, there's a lot of things that are missing. So you don't see anything describing how exceptions are going to be handled. And maybe that's because they think there won't be any exceptions. But if you're going to interface to Objective-C code throws exceptions. So you got to have some way to catch exceptions. So there's going to have to be some exception handling. And I don't think that has been finalized and documented yet. So I don't know what the whole language is. Also, as we're looking at the other languages that are sort of in this class, like Go and Erlang, they're not just taking care of tidying up the syntax, they're also dealing with the big issue of our time, which is concurrency. And we don't see any support directly in the language for concurrency yet. And we would think that we would see something. Maybe the argument is that the dispatch queue API is already there and we'll just use that. So it doesn't have to be part of the language, it's part of the libraries. But most modern languages designed for concurrency have some sort of things built into the language for that. And it would be great to see something similar to Go routines, where it would be very easy to fork off lightweight threads and then talk to those threads through a channel and not have to deal with as many locks and things like that. What was I going to say there? I was going along somewhere. Anyway, go. So I'm actually really excited about Swift. I don't think it's quite there yet. I am excited to sit down and start writing my first few projects, writing it. If I were betting my house on a project, at this point I would still stick with Objective-C. I don't think you ever want to be the first person to deal with the technology and bet your house on it. I think you want to let other people find the bugs and issues, come up with best practices for it, give Apple a chance to fix it a little bit before you start betting your house on it. So it's not that I'm not excited about it, but I don't think there's a big rush. That said, I am going home immediately after the conference and starting rewriting all my materials in Swift. And so you can figure that sometime in the autumn you can come to the Big Nerd Ranch and take a class on iOS or Cocoa development in the Swift language. So I'm looking forward to that. Gab?
Do you think Apple is rewriting all their apps, or maybe they've already rewritten all their apps?
So the word, that, and I don't know anything, but the rumor going around is there's not a whole lot that's been written in Swift. And that's actually why I have concerns. There are definitely technologies that Apple has shipped out to developers before they have used very much themselves, and you can tell because they're weaker and they fix them later on. So the answer is the only large app that the biggest app I've heard that has been written in Swift is the WWDC app, which is a fine app and has several pages and things, but overall it's not a very big and complex sample case. So I would definitely give Apple a chance to test it more before you bet your house on it. Other questions, comments, complaints? All right, let's talk about the future of networking a little bit. What a lot of people are working with right now is web services. So your iPhone app makes a request to essentially web server, gets some data in JSON, uses that, reformats it, displays it to the user, maybe caches it away a little bit. And if the data changes over time, often you'll just keep polling from time to time. This is probably not the future of a lot of things having to do with networking. When we talk about massively multiplayer games, when we talk about collaboration between people, so both people can be looking at the data and manipulating at the same time, like you see in Google Docs. When you talk about sync, so when you have multiple devices and you want to have the information on both of them stay in sync. When you deal with the Internet of Things, there's a lot of two-way communication that has to happen between your Nest thermostat and the Nest server. And polling is a very inefficient way to do it and a very non-responsive way to do it. So much as I love NS URL session, I think that's a wonderful step forward. What I wanted to talk about was not web services, but the sorts of things that give us two-way communications between the client and the server. Okay, so that's my goal today. And I'm not saying that web services are bad. I'm just saying that looking forward at these sorts of problems, and these are really the interesting problems for the next decade, we need to start thinking about two-way communications between the client and the server. So not web services, the other thing. And this is the model that I think of in my mind, is that the server keeps hold of the truth. And when the truth gets changed by one of the client, it needs to then send notifications down to the other clients who are looking at that same data that the truth is now changed. And there's some race conditions and things, but overall, this is the kind of problem that requires two-way communications. Right now, if you're doing it with polling, these devices just call up every once in a while and say, has anything changed, and get notifications that way. But it's not as immediate and it's not as efficient because all these devices are polling. And when you start talking about the Nest, for example, you're talking about a lot of devices. A single house can have several of these Nests in them. It's not going to be efficient to keep polling. One of the big things that you'll want to worry about is the idea of doing incremental updates. Instead of going and fetching all the data every time, you need to be able to say, I need the data that has changed since last Tuesday, last time I ran this application. So clever use of caching is also going to be a really important part of this problem. I'm not going to talk about caching, really. I'm really going to focus on the networking code end of the problem. Okay? All right. So DARPA, the military, gave us the internet. And the internet was based on the IP protocol. And on top of the IP protocol, there were two different, I guess they're protocols as well. There was the UDP, which sends datagrams, so messages, chunks of data. And then there was TCP/IP. So UDP is really nice. It's very message-oriented. You put together a buffer of bytes. You send that buffer of bytes across to another machine. It gets them all, or it doesn't get them at all. The problem is that you're not guaranteed that those packets are ever actually going to get there. In reality, if there's a decent connection between the client and the server, they nearly always get there. But you're not guaranteed by the system. There's not this sort of acknowledgement that you get when you do TCP. There's no order guaranteed. And one of the things that's nifty about it is that you can use it for multicast. Now, given that it's not guaranteed to arrive and the order is not guaranteed, you can imagine that what you end up dealing with is stuff where it's real time, and if the packet gets dropped, it's not a big deal because you have to go on anyway. So we talk about a lot of voice over IP type stuff. If the packet didn't show up in time, it doesn't matter because the conversation has moved on. We're getting other packets. We're going to be using that. So we tend to use UDP for these sorts of problems. Okay? Multicast. Multicast is a neat idea where you send one datagram out and it goes to a bunch of different machines. It's not something that works typically very well over the internet. It's something that in your company you can set up the routers so they actually support this multicast. So you don't see a lot of people using multicast in internet type systems. But it's kind of a nifty idea. So if you're dealing with something on a local network, I could imagine if you could set up a system where you imaged servers and imaged machines in a classroom. If you wanted to send out the images to all of them at the same time, you could use multicast for that. So think about UDP. People don't think about UDP enough. It's very lightweight. It's very fast. It's just not really very reliable. And so here's what it looks like. You set up a socket. And then you use the send to command. You say, here's the buffer that I want to send, and here's the address that I want to send it to. I'm going to skip all the stuff for setting up the addresses. That's the really hard part. Anyway, you can look online. There's a whole bunch of people setting up those addresses. One way that you can get the address is through Bonjour. So some machine advertises a service. You get hold of the record, and there is actually a address structure as an NS data there. You just copy it into the structure and you use it, which confused me terribly. I'm like, what am I supposed to do with this NS data? You just copy it into memory and everything works. Phenomenal. One of the tricky bits with these addresses also is that we are in a time when we're transitioning from IP version 4 to IP version 6. And you really should do the right thing, which is try and look up the host based on IP version 4. And then if you can't find an address there, you go and you look at IP version 6. These two structures have two different sizes, so you'll have to worry about that as well. So getting the address, I'm not showing it. It's actually a really messy process, but there's examples of it on the internet. Go to Stack Overflow, you'll find something. But this is how it works. Send to, you send the packet off, and you hope it shows up at the other end. On a Mac or an iOS application, the more puzzling part is the other way, where packets are coming in and you want to receive them. The multi-threading is very hip right now. Everybody wants to multi-thread. And multi-threading is great because you can use all those cores on your computer at the same time. But when you talk about forking off a thread to wait for something, that's really not a very powerful use of multi-threading. You're just forking off a thread, it's going in and waiting for something. That's not useful. It's just unnecessarily dangerous. Apple gave us something that was really handy for waiting, and that is the run loop. The run loop waits for stuff. So you're probably used to the run loop waiting for events from the user. So when they move across the screen with their finger or their mouse, you get the events coming into the main thread through the run loop. But the run loop can have other sources. And one of the sources that you can have is a socket. So if you want your machine to receive UDP packets, what you do is you create another socket. And in this case, you'll be using Core Foundation. So you create a socket signature and a socket context, and then you create a socket reference. Once again, I'm going to kind of leave out how this is done, but you can see that you take that address structure and you copy it into a NS data, right? Just like I was talking about Bonjour. And then you can use that to create the signature and then create the socket out of that. And then you take this CF socket ref and you put it inside a run loop source and you attach it to the run loop. And now you'll receive a callback whenever a UDP packet comes in. You'll receive the callback on the main thread. You can then fork off a thread to do the processing you want on it. Maybe you want to parse it, slice it, dice it some way. But in the end, you got to bring it back to the main thread to display to the user. So this is a really nice, efficient way to do this sort of work without having to multi-thread. Create a run loop source and attach it to the run loop. Can I answer questions on that? Once again, multi-threading is the hip thing, but run loops are really handy. And anytime you're multi-threading, maybe you should think about, is there some way I can do this without multi-threading using the run loop instead? Okay. All right. Okay. Then when the data comes in, you get a callback. It's just a C function. There is a type that tells you what sort of callback you're getting. In this case, I'm interested in receiving the data. So I can ask, what is a type? If it's the data callback, then I can get the data and put it into an NS data object right there, toll-free bridged. All right. Now, if you do UDP and then you get really obsessive about what's happening to the packets that aren't arriving, well, then you might create two-way communications and say, hey, you know, I didn't get packet number 6. Could you resend that? And it gets sent for you. You keep track of the numbers. And so what you're essentially doing is rewriting TCP. So you might as well just use the TCP protocol. It's all built into these platforms, and it is optimized for the real world. So let's talk about TCP a little bit. With TCP, it's a connection-oriented API. So you create a connection between the server and yourself. Let's call it the server. And then you can write to that as if it's a file. And when you write to it as a file, it eventually gets flushed through to the server. And that's one of the things that's a little bit surprising to me, is that there isn't a flush command on this where you say, okay, I'm writing this. Now would you flush that message off to the server? What happens is that whatever you write into that gets sliced up into little packets and sent off. And they arrive at the server over time. And as a result, you may get partial bits of the data you need. Maybe you need 128 bytes, 64 show up, and you know you need to wait for the other 64. And so UDP comes in messages of a set size. TCP, it trickles in as it wants to, and you're responsible for breaking it up into frames. And this is actually just kind of a hassle. Is always look, you know, typically you'll put a byte count at the beginning of the message, and then you'll wait till all those bytes have arrived. You'll be accumulating them in, let's say, an NS mutable data. And then when you have the whole thing, then you'll start to process it. But it's kind of a hassle. But given that you have to go through all this, just like UDP, I convinced you should then move up to TCP, there's actually a really kind of nifty library, which is NanoMessage. And what it does is it's an API very similar to sockets, but it does things in message-sized chunks. And you can say, here, send this message to the server, and it won't do anything on the server until the whole message has arrived. So you might think about this. It's open source. It's under an MIT license, so you can put it into your apps, and then you can sell them. The guy who wrote it worked earlier on a thing called ZeroMQ, and he thinks that this is a really nice extension of this idea. Not only does it take care of this framing problem in TCP for you, it also takes care of common topologies for network problems. So, like, for example, pub/sub. So you can subscribe to a server, and when a message goes out, it gets sent to all the people who have subscribed to receive that type of message. So I would recommend that you look at NanoMessage. I'm going to give you a quick example here. this is sending a packet out through what they call a pipeline. So this is the pipeline is the simplest case. You have one thing on the receiving end of the pipeline. You have one on the sending end of the pipeline. You create a socket. You do NN connect to a particular URL. The URLs can be IPC, that is, two processes on the same machine. They can be inside a single inproc, so that's between two threads in the same process. And you can also do TCP, so it will use TCP IP to send it across the internet. And then you give a URL including what port number you want it to go into, and then you simply send it. So here I've got a data. I'm saying write that out with these number of bytes. And there are some options there. They're not terribly interesting. But that's how you send a nano message. It's a lot simpler, actually, than doing TCP IP. It takes care of the host lookup for you, and so you don't have to fill out that address structure. Check it out. I think you'd like it. Receiving. Receiving at the other end, you create another socket, and you bind. So on the sending end, when you're creating an endpoint that's distant, you use connect. So you're talking about where I'm sending it. On the receiving end, you do binding, where you claim a port number on the local machine. And you can specify which network device as well. So you can say, I want to wait on this Ethernet jack for this port number. And then you call NN receive, and it blocks, waiting for that message to come in. So this is an example where I couldn't figure out a good way to make a run loop source on it. So the way to do this would actually be to fork off another thread and then run this blocking function call. The function call has a timeout. So something you could do is you could just keep polling to see if anything has shown up. Or you could set it in a loop so that it waits, let's say 3 seconds. And then it goes through the loop, checks to make sure if you wanted it to terminate or not. Because disconnecting is also something that you typically want to do. But yeah, when you get done with the data, you need to call free message so that it can get cleaned up. Questions on nano message? Yes? Yeah, so I put a time limit on that, and then I would put it in a loop. And then I would have Boolean like please terminate. And so when I'd have a call a cancel, it would turn the please terminate to true. And when we got to that point in the loop, it would pop out. And that way you could disconnect. Yeah. Okay. Other questions? Yeah. Stay close to the podium. Oh, I'm sorry. Yeah. I have a bad habit of just roaming about. Where am I? Okay. So nano message. Where was I going? All right, yeah. So nano message is wonderful. However, on the internet, if you're on a local network, nano message is super. So if I had to do a cluster of servers and send messages around between them, nano message would be awesome. On the internet, there are all sorts of firewalls, and you need to encrypt the data going across. And then you've got also to support JavaScript clients. So it turns out that there was a solution for this that I really was not ready for, that I had always poo-pooed as some silly JavaScript idea. And it turns out that it's really great. WebSockets. So WebSockets are set up, most of the firewalls in the world now let WebSockets go through very elegantly. It does the framing for you. So there is a count of the number of bytes that is in that WebSocket message. And so the whole chunk comes through. You don't have to worry about taking care of the framing yourself. It comes in WS, which is unencrypted, and WSS, which uses TLS encryption to handle the communications for you. And one of the things that's nice is that once you've written the server for this WebSocket server, not only can you use it from Android and iOS, you can also use it from a JavaScript client as well. So there is a wonderful library called Socket Rocket that the guys at Square wrote. Mike Lewis wrote it. It's out in the Apache license. And it's very, 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 very elegant. This is kind of what it looks like. When you want to receive a message, you set up a WebSocket. And then you get these callbacks as the delegate. It did receive a message, or it did close, so you can know when the server closed it on you. And when you send it, you just send a message, and that can be either a string or an NS data. The WebSockets have sort of separate protocols for the two. And you get an error if something goes wrong as the delegate. You can set up dispatch queues so that these messages, these callbacks, occur on a background thread if you want them to. It's very, very nifty. That's kind of the moral that I wanted to say is, it turns out WebSockets are a great solution. Use them. And this Socket Rocket library, that's the future. When you write the server, I've actually really started to like Go and Erlang's approach to dealing with keeping a whole lot of ports open, a whole lot of sockets open to a bunch of clients. These lightweight threads that the languages create and this idea of channels is a very, very efficient way to do it. Not only is it efficient on the machine, and it's very efficient for the machine, but it's actually efficient in terms of code as well. So if you download the Socket Rocket code, you'll get a Go server for running a chat server. And this is the code here. This is the whole thing. This is a chat server written in Go. Very high performance, and it works beautifully. So I would recommend that you definitely, if you have to write a server, that you think about one of these CSP languages, communicating sequential processes. Lightweight threads talking to each other through channels. One of the problems you will have is actually hosting this server. So let's say you like the Google App Engine, you try and put your Go routine up there, it will fail. As soon as you try and open up your WebSocket, it's not going to work. But if you upgrade and you do the compute, the cloud compute, what do they call it? Google Cloud Compute, yeah. You can spin up a Linux machine image really easily, and it runs it there, and they just bill you as you use it, and the bill rate is very, very reasonable. So you can't do it on App Engine, but you can do it on this Google Compute Cloud. So with all the hosting services, if you want to write a server like this, you need to make clear, you need to double check that they are going to let you have these WebSockets sitting open for a long time. Okay? All right. I'm running out of time, so I'm going to keep moving. This is the bubble chart that is going to be on your whiteboard in 2 years. So I'm giving you a heads up. This is the way the world is going. You're going to have your iOS, Android app with a cache. That could be SQLite. It could be some sort of a key value store. JavaScript app, same thing. You're going to be able to use the HTML5 storage stuff. You'll be talking WebSockets to some sort of a CSP written server, maybe Go or Elixir or Erlang. You're going to have some sort of authentication and authorization service where you can figure out who has access to what resources. And then you're going to have a sense of the truth. But it's not just going to be a database of the current state of the truth, but also what has been changed over time, a log of how the truth has changed, so that when someone disconnects for a couple of days and they come back, they can say, what has happened to the truth in the last 2 days, instead of downloading the whole thing again. So we're going to have these log-type structures, a log of what the changes that have been made, timestamps in some way, to tell you what's changed so that we can do syncing effectively and efficiently. And this is the diagram that's going to be on your whiteboard one day. Because we're all going to be solving this in very specific cases. The really interesting person in this room is the one who figures out a general solution to this. Right? You are going to be the next parse. You're going to be the next platform as a service guy if you can solve this problem in a general way for all of the rest of us. So that is a huge opportunity. It's like $1 billion opportunity. So you might think about that. And that brings me to the end. I do this because I just enjoy it, but it is also another chance for me to plug my company, Big Nerd Ranch. We develop apps for people. We train people and companies how to do development on both iOS, Android, Mac OS X, and JavaScript. We would be delighted to come out and teach you, or you can come to the ranch and take a class with us. It is the all-inclusive experience, just like Club Med. We also write books. Yes, we are working on Swift versions of all our Apple-related books. And we are always hiring. If you are a great programmer, you're a kind person, and and curious, we would love to talk to you about coming and working for us. Go to our website, bignerdranch.com. Thank you very much. And I've used up all my time, so I'm not going to take any questions, right? All right.
He has been writing Objective-C for 20 years. He works at Next. He is worked at Next. I apologize. I'm glad you're here.
I'm glad I'm here too.
He's written books on iOS, Cocoa, Objective-C. He's the founder of Big Nerd Ranch. He's currently focusing on coding, teaching, mentoring, and writing. Aaron Hillegass.
Thank you, Amber. And more than just thanks for the introduction, I think this conference is really very important. There are two parts of the community. There's Apple, and there's the people who write apps for Apple technologies. And there has to be a dialogue between them. And WWDC is really a lot about Apple talking and telling us what we should be doing. And it's nice that there's an alternative voice coming from the community and speaking to everyone at large. But hopefully there's messages coming out of this that are also getting to Apple. So I really want to say thank you, Amber and Judy and everybody involved with the conference for putting this on. I know it's a lot of work, and I think everyone here really appreciates it. Advanced Mac OS X programming, so that it became clear it was not about all the core frameworks. But I love that diagram. When we got a distributor, Pearson now distributes our books, they said that cover had to go because it looked like a 1950s engineering book, and it was too scary for people. And then once I had heard about this idea of it being too scary, when I did the Objective-C book, I went the total opposite direction. We put a tricycle on the cover, and everybody felt comfortable getting the tricycle book. And then this is our iPhone programming book. Back when it was called the iPhone SDK was the first edition of that book. So it's been a really fun adventure writing applications, writing books, and being part of this community. And so I thought that what I would talk about today is network programming. But first, I thought it might be fun to talk about Swift for a second. I'm sure that everybody who gets up talks about their opinion of Swift. I have actually read the whole Swift book now. I sat down, I read the whole thing from cover to cover, and I'm really excited. I think it's a really nice cleanup of the Objective-C language, and it's going to be abstract enough that the compiler can do a lot of things for us that it hasn't been able to do in the past. I think that it's also not really done yet, and if you look at it, there's a lot of things that are missing. So you don't see anything describing how exceptions are going to be handled, and maybe that's because they think there won't be any exceptions, but if you're going to interface to Objective-C code throws exceptions, so you got to have some way to catch exceptions. So there's going to have to be some exception handling, and I don't think that has been finalized and documented yet. So I don't know what the whole language is. Also, as we're looking at the other languages that are sort of in this class, like Go and Erlang, they're not just taking care of tidying up the syntax, they're also dealing with the big issue of our time, which is concurrency. And we don't see any support directly in the language for concurrency yet. And we would think that, so, thanks. So, before I get started, I wrote these books. I thought I'd start with the first edition of each of them because most people don't have the first edition. My favorite really is the first edition of the Cocoa book, where they gave me the brown cover in the 1970s font and the black and white picture of the inside of the Eiffel Tower. When they sent me the first kind of drafts of the cover, there were things like a slide rule on it. I got to say, they thought there was Mac programming in 2001. They're like, oh, well, let's do all sorts of obsolete technologies. And it was only when it actually started selling some reasonable number of copies that they got me a real grown-up designer who did the covers that you see now. And then this is actually my favorite cover we did. This was our Core OS X and Unix programming book, which was sort of about Unix internals for the Mac, and it talked about multi-threading and memory and file I/O. And that was before Apple started using Core for everything under the sun. And so we had to change it then to say I'm going to talk. Is it done? All right. Should I stride out after you make your introduction? I'll just come stand with you. That way I can correct you if you say anything incorrect about my existence.
Hello. Hi. So our next speaker you may already recognize.
That gives it away.
I think.